Hi everyone. Today we will look at the number one object in the solar system. The star of the show, if you will. The Sun. The Sun is a G-type main sequence star that makes up about 99.86% of the mass of the solar system. With an absolute magnitude of plus 4.83, the Sun is estimated to be brighter than roughly 85% of the stars in the Milky Way, with most of them being red dwarfs. The Sun is a population 1, or heavy element-rich, star. Its formation may have been triggered by shock waves from one or more nearby supernovae. This is suggested by a high abundance of heavy elements in the solar system, such as gold and uranium, relative to the abundances of these elements in so-called population 2, heavy element-poor, stars. The heavy elements could most plausibly have been produced by endothermic nuclear reactions during a supernova, or by transmutation through neutron absorption within a massive second-generation star. The average distance between the Sun and the Earth called an astronomical unit, about 150 million kilometers. This unit of measurement helps us visualize the distance between objects inside our solar system. The Sun is roughly halfway through its most stable phase of life today. Over 4 billion years have passed without any significant changes, and it will continue to stay relatively stable for another 5 billion years. But it will undergo significant changes, both internally and externally, once hydrogen fusion in its core stops. The Sun formed about 4.6 billion years ago from the collapse of a gas cloud that consisted mostly of hydrogen and helium and that probably gave birth to many other stars. At this point in its main sequence stage, the Sun is converting hydrogen into helium through nuclear fusion reactions in its core. The Sun's core converts more than 4 million tons of matter into energy every second, which produces neutrinos and solar radiation. So far, the Sun has converted around 100 times the mass of Earth into energy, which represents only 0.03% of the Sun's total mass. The Sun main sequence is approximately 10 to 11 billion years long. It's currently at the midpoint of that life cycle. The Sun does not have enough mass to become a supernova. Once it runs out of hydrogen, in 5 billion years, the core will contract due to his own gravity. It will then start fusing helium, slowly turning into a red giant over the billion years, destroying the inner solar system in the process. When it reaches its ultimate size, it will be approximately 256 times bigger than it is currently, and it will have a radius of 1.19 astronomical units. I refer you to Science Asylum video on this subject. The Sun takes approximately 225 to 250 million years to orbit the galactic core, at a distance of approximately 24,000 to 28,000 light-years. In other words, the Sun has orbited the galactic core roughly 20 times. A final warning. I am sure you already heard this, but better safe than sorry. When viewed with the naked eye, the Sun's brightness can cause pain. Looking directly at the Sun causes visual artifacts and temporary partial blindness. It also delivers about 4 milliwatts of sunlight to the retina, slightly heating it and potentially causing damage in eyes that cannot respond properly to the brightness. Viewing of the direct sun with the naked eye can cause UV-induced, sunburn-like lesions on the retina beginning after about 100 seconds, particularly under conditions where the UV light from the Sun is intense and well-focused. Viewing the Sun through light-concentrating optics such as binoculars may result in permanent damage to the retina without an appropriate filter that blocks UV and substantially dims the sunlight. When using an attenuating filter to view the Sun, the viewer is cautioned to use a filter specifically designed for that use. If you wish to observe the Sun, please purchase the proper equipment from an astronomy-specific store that can advise you correctly. Hope you enjoyed this video. If so, make sure you like, subscribe, and share. See you next time.